Planets outside our solar system, often known as exoplanets, existed solely in theory and science fiction for decades. Planets light years away seemed impossible to find since the relatively small worlds would seem billions of times fainter than their parent stars. However, astronomers have successfully developed indirect detection methods in the last 2 decades. And one of the aftermaths was the detection of Eris, an exoplanet just after Pluto. On February 28, 2004, Michael Brown reported the discovery of Sedna, an object believed to be almost 2,000 kilometers in diameter and rotating between the Kuiper Belt and the inner regions of the Oort cloud. Everyone thought the solar system had discovered its 9th planet, but that was only for a brief time. The planetoid Sedna's diameter was swiftly reduced, and the number of planets was restored to their former number. Mike Brown then announced the detection of a second large object, tentatively named 2003 UB313, on July 29, 2005, after only 517 days. The discovery's outcome was eventually revealed. It was named after the Greek goddess Eris, the goddess of strife and discord in Greek mythology. The name Eris was chosen for the dwarf planet to reflect the significance of its first discovery on the classification and knowledge of celestial bodies, which sparked a dispute and disagreement about the definition of a planet. Despite its downgrade, Pluto stayed on everyone's lips and in their hearts, whereas Eris, having missed the train that would have brought it fame, was quickly forgotten. Most likely because it was thought to be just one of several planetoids that would be discovered in the Kuiper Belt in the future. In fact, nothing quite comparable has been discovered in these remote locations since 2005. Eris is the largest known object since the discovery of Triton, Neptune's massive moon, in 1847. Eris, however, deserves far more attention than it has received thus far. We may have to travel as far as the Oort cloud, which is an anticipated group of frozen objects that are further away from the sun than everything else in the solar system, to discover something much larger, and even then, we may not find something more deserving of the name planet. Eris was found by astronomer Michael Brown and his collaborators Chad Trujillo and David Rabinowitz on January 5, 2005, using pictures that were taken by telescopes at the Palomar Observatory in California. Specifically, the astronomers used the Palomar Observatory's Samuel Oschin telescope to acquire photographs of the sky and identify the presence of Eris. These photos were processed and compared to other observations to confirm Eris's findings. Since its discovery, Eris's diameter has been gradually refined and reduced. From the images taken by the Hubble telescope in 2003, Eris's diameter was 2,397 kilometers. The usual approach of using Eris's distance, albedo, or its reflectivity and apparent brightness was used. Albedo is the astronomical term for a celestial body's surface reflectance. It reaches its maximum value of 1 when all incident light is reflected. When no light is reflected, the least albedo value is 0. The first situation involves a perfectly white object, whereas the second involves a completely black object. With the exception of Saturn's 6th largest moon, Enceladus, Eris has an estimated albedo of 0.96, more than any other major body in the solar system. Eris's higher reflectivity is thought to be due to rising surface ice, which is increasing due to its present orbital distance from the Sun. When the diameter of Eris was compared to Pluto's diameter, which was calculated at the time to be 2,370 kilometers, Eris seemed to be slightly larger than Pluto in the best-case scenario. But to be accurate, as this is science, it's tough to say whether Pluto or Eris is larger. This assessment is compounded further by Pluto's atmosphere, which interferes with images of the planet's solid surface. The Spitzer Space Telescope was used in 2007 to refine the dwarf planet's diameter, which resulted in a size of 2,600 kilometers. A stellar occultation, an uncommon occurrence, occurred in 2010. The occultation of such a distant object in our solar system has never been detected. The findings call in question previous observations, particularly those made by the Spitzer Space Telescope. According to evidence collected from its occultation in front of a star, Eris has a diameter of only 2,326 kilometers. Later in 2015, the New Horizons mission estimated Pluto's diameter to be 2,376 kilometers. Pluto is currently confirmed to be the largest dwarf planet, albeit by a very thin margin compared to Eris, if no other changes occur. Well, now that we know about its size, let's look at its mass. Obtaining an approximation of the mass of a single object like Eris is undeniably difficult. Fortunately, the discovery of dysnomia, which is the name of Eris's moon, has remedied the underlying problem. In astronomy, knowing a satellite's orbital period and distance from its home planet is sufficient to compute the mass of the parent planet using Kepler's third law. We won't dive into the exact details of the math behind it, but a simple calculation revealed that Eris's mass is 27% greater than Pluto's. As a result, Eris's density must be greater than Pluto's. Eris has a density of 2.5 grams per cubic centimeter, which is significantly more than Pluto's density of 1.75 grams per cubic centimeter. For comparison, water has a density of 1, whereas our planet's average density is 5.5. From this, because Pluto and Eris look to have equal diameters but different densities, their composition must have been somewhat different. Eris is most likely formed of far more stony and dense material than Pluto. Some astronomers say the composition should be roughly 70% rock and 30% ice. However, they're only hypotheses. By now you might be curious about what the surface is like. The surface temperature varies between -240 degrees and -216 degrees Celsius due to the planet's fluctuating distance from the Sun. No surface features can be detected directly from Earth, regardless of the telescope's location. But to understand more, indirect measurements such as spectrum analysis are necessary. Spectra were taken from Hawaii's 8-meter Gemini North telescope on January 25, 2005, and infrared spectrum analysis confirmed the presence of methane near the surface. Additional testing found excessive carbon monoxide and nitrogen levels similar to Pluto. Sublimation processes will be engaged as Eris approaches perihelion, allowing surface gases to escape and creating a thin atmosphere. The surface temperature will then steadily decrease as Eris moves away from the perihelion until it reaches its lowest point at the aphelion. As temperatures fall, air gases will refreeze and return to the surface, allowing for resublimation. Because methane is highly volatile at these temperatures, sublimation processes may be conceivable. However, this raises another question. How can methane abundance be explained if it is so volatile that sublimation is possible? There are two possibilities. Eris has always remained at such enormous distances from the Sun that sublimation has never occurred. Second, methane that escapes from the surface may be replaced from within. There are no other facts known about Eris's surface. We can only tell that it has a different color than Pluto and Triton. In contrast to Pluto and Triton, which have a reddish color, Eris, like many other Kuiper Belt objects, appears gray. It's also the largest object never visited by spacecraft, and its great distance and small size make viewing the dwarf planet difficult without sophisticated telescopes and technology. It was also hoped that the James Webb Space Telescope would be able to observe Eris, but it seemed that its goals were bigger than that. Regarding probe inquiry, various studies were undertaken in the 2010s for follow-up missions to investigate the Kuiper Belt, including Eris. We can only hope that as technology advances, space travel will be simplified in a way that we can reach objects like Eris in no time. Otherwise, currently, it's just a fantasy destination for us.